Don't be afraid. You can be apprehensive, you can be concerned even, and you can be cautious, but don't be afraid. That's the nice thing about mechanics and mechanical practical skills. A lot of these things that you can do hands-on, woodworking, metalworking, stoneworking, there's some people who will gatekeep the skill, but the cool ones don't, I think. And just like any other skill, like sewing or cooking, once you learn the general rules of it, you know what to do to avoid hurting yourself. And here's one of the great big differences between using a gas to weld. This is a flammable gas enriched with oxygen. So acetylene burns, and oxygen doesn't actually burn, oxygen supports combustion. So if you use a torch with a flame, you're oxy-fuel welding, a fuel gas along with oxygen to make it hotter. There's no electricity. When the power goes out, anyone who's got an oxy-fuel torch is gonna be like the only person who knows how to weld until, the fuel gas runs out. TIG welding is using electricity to make an arc to fuse the steel. Using actually old school combustion, just like you're burning papers, using electricity, like if you sever a wire or some equipment goes through some power lines and there's melted metal, using the heat of electricity to melt things. Arc welding, fuel gas welding. Two completely different processes to achieve a pretty similar result. This is a lot more clean and precise. And you can adjust it to weld on aluminum. I've seen aluminum welded with these things before, and it's amazing. I should try it someday. But back to the safety and predictability, I want to show you something with these. It's one of the first things that you've got to wrap your head around when you're a new welder. And that's the fact that the electricity is always going to follow the path of least resistance to the ground, which means that if I go to weld with this, I hit my pedal. This is not energized right now. This is a non-consumable electrode. I'm not foolish enough to put my tongue on it and touch the table tube because my power source is on. It shouldn't do anything, but it's just a foolish thing to do while it's still hot and, something could happen. But this isn't energized yet. Here, I'm touching my tungsten and I'm touching my table right now, and it's not energized. If someone were to come along and stomp my pedal, or if something were to roll and fall on my pedal right now, I'm gonna get a jolt because it's gonna go through me into the table. So no matter which direction I hold my torch, it's always going to go to the closest point that is grounded. And sometimes that's a lot of fun when you're welding because you forget what is grounded around you, especially when you start welding in like these big boxes or panels. Like maybe you'll go to put your stick in your stick welder stinger and you go to like flip your lead to get more comfortable or something like that, and you flip your stick up into the ceiling above you, but the ceiling above you is energized, or it's grounded, and so you strike off on something above you or behind you. This is not run by electricity whatsoever. It's just a fuel gas. So there's the acetylene. I'm gonna add a little bit of oxygen. Once you get that nice little foxtail going, you add oxygen. You keep adding oxygen until you get that inner cone. Right about there. It's a little harsh, but you could weld with that. It looks different on the phone. Welders, trust me, in real life this is perfect. I've got about a 1/4 inch long inner cone right now. On the camera, it's showing up like this, but in real life it's only this big. There you go. There, that's the inner cone. Oh, that's so weird. It disappears. If I turn and face it at me, it's going to burn me. If I face it that direction, which is to my left, it's going to burn whatever's to the left. And if I point it down, it's going to put all the heat down. Wherever you point this is where the heat is. If you gotta, speed dry a little bit of paint, sometimes you can kind of gently go over it with a torch. When you're learning how to weld with this, you preheat the joint with it. If you go back into my videos, like 5 before this one, I do 9 processes, and one of them is oxy-fuel welding. Just to take your filler rod, preheat your joint, preheat your rod, and tack each end, and heat it up until it's liquid, and you drop some filler rod in. Then you move it, heat it till it's liquid, drop a little filler in. Move, heat it till it's liquid, drop a little filler in. Pretty soon that whole joint is mostly preheated, so you don't have to stand there and wait. You're just kind of pushing that pedal along. Move, dip, move, dip, move, dip, move, dip, move. And that's how you weld with acetylene and oxygen, or any other fuel gas and oxygen. There aren't a whole lot of curveballs. It's really intuitive, or at least it is to me. I would love to start everyone out first on oxy-fuel welding, especially if you haven't played around with fire before in your life. If you've never seen how steel melts, or if you've ever played with thermoconductivity, if you've never grabbed a pan off the stove, or if you've never grabbed an aluminum cookie sheet out of the oven versus a steel cookie sheet. Oxy-fuel welding isn't used a whole lot in industry that I know of, but it is hugely important for teaching thermodynamics of steelwork. TIG welding is kind of like the electrical version of that. It's often considered the most difficult process to learn and use, and it is costly, but to me, it's the most fun. I love my TIG welder. I've got 2 of them because you can do any material, almost any thickness, any position, almost any condition. The downside is that you've got to be a little bit more skilled to use it, but that just means more practice, and you've got to rheostat control. I like a foot pedal, so I've got my dominant hand working the torch, the heat source. You don't use your dominant hand to feed wire in. It feels like you're doing the work with the wire filler end. You're not. You're doing the work with the heat. Where you put the heat controls everything in welding. It's 100% about heat control. A TIG torch works the same way. You press down on that foot pedal as you want the amperage to increase, as you want the flow of electrons to go harder. It works mostly the same way as your oxy-fuel welding, where you get your joint set up. You don't preheat it with this torch, generally. Once in a blue moon I've done that. And remember, no matter what angle you're holding this at, the arc is always going to be attracted to the ground. But you still can affect where the heat is going by the resistance of the shape of that arc. You step on the pedal or you hit your finger trigger if you're a crazy person, and you make a little molten puddle, and then you dip your filler rod in, and then you move over a little bit, and then you dip in your filler, and then you move and you dip, and you move and you dip, and you move and you dip, move, dip, move, dip, move, dip, move, dip. And that's where you can get your own technique. Some people just make a puddle and go along over the filler rod and wash over it. Some people do a zigzag. Some people do this little step method. To me, it depends on entirely on the joint, entirely on the job. Sometimes, especially if you're tube or pipe welding, you get to walk the cup, which is basically setting your tungsten stick out just perfectly so that you can use the edge of your cup as a guide without slamming your tungsten into the joint. But speaking about predictability, my table is grounded and my torch is hot. I took the ground off of this table so that I can show this in the video. What you're going to see is a little blue arc that looks like lightning jumping out of this, which is just a little high frequency start that these welders have to get your arc going. You would never do this in a normal situation. This is only for demonstration purposes, just so you know. If I hit the pedal now, see how it's trying? Sometimes on a busted old machine, they will do this right through your gloves while you're trying to weld. You'll get a little high frequency nail. I could put my ground clamp back on the table and it's going to do the same thing with a full arc. It's going to try to go straight into the table. So even if I'm pointing it to my left or to my right or up, it's still going to try to go straight down into the workpiece, into the table, into the ground. So that's the weird part about gas welding versus arc welding, but it's also the really cool, fun, and predictable part, because with gas welding, you know where you are putting your heat because you're pointing your flame at the work, at the job. Think about it a little bit reversed from a match or a lighter. That's one of the first things that I taught my kids when they're using a lighter to start a fire. You don't hold your lighter like this. Like when you're lighting a jar candle, you're not going to be sticking it down in because fire always climbs up. When I teach them how to build a fire in the fireplace, fire always climbs up. So if you are starting a fire, don't go in from the side, even if that's where the paper is, even if that's where the tinder is. If you can access it from underneath, go underneath the fire, because the fire is going to climb up through all that stuff you're trying to burn. With electricity, the arc is always going to go toward the ground, even if you put the ground over here or on your buddy's belt buckle. Oh, I told a story on here about a kid who got arced out on his belt buckle once. It didn't end well for him. That's on my Story Times playlist. There were a lot of great questions on that last video. I'll see if I can get to them.